Well, here we are back again, Math 30-2, Chapter 6, Lesson 3, and this is a continuation of the previous videos from Lesson 3. We're going to look at this one example here, which is a kind of half-life question, a bit of an unusual half-life question. We'll use this to explore the idea of what the half-life equation looks like and what each term means, and then we'll kind of define the terms in a more general sense. So in this situation, we have someone doing some underwater, and as you're diving, the amount of light decreases the deeper you go. So on a sunny day off the coast of Vancouver Island, a diving team recorded 100% visibility at the surface of the water, but only 25% visibility 10 meters below the surface. The team determined that the visibility for the dive could be modeled by the following half-life exponential function. So that's what we have here. This is a fairly typical half-life exponential function. It's called a half-life because our base here is a half, and we're looking at, in this case, a distance where the amount of light decreases by a half. So here in this equation, we are told what each term represents. So this A sub 0, sometimes that's called A naught. That's the percentage of light at the surface of the water. So we'd say that's an initial amount. So an amount at time, or in this case, depth, 0. So when x is 0, the amount of light will be this number in front. So it corresponds really to the y-intercept if we were to graph. X in this case is a depth in meters. So that's what the x value represents. H, this is the number that's kind of unique here, where this is the depth in meter where there's half the original visibility. So this ties back a little bit to the question we did in the previous video, where we were looking at the amount of a drug or medication that's left in your blood system after 4-hour periods. So there we set up an equation where we had a 4 in the denominator of the exponent. And so that would be kind of similar to a half-life type of situation, where in that question, the h was a 4, and the x could be a number of hours rather than a number of 4-hour periods. So that was that previous question. Back to this one. The A of x represents the percentage of light when we have a depth of x meters. So for this question, let's summarize the information we're given. So A sub 0, that's going to be percent of light at the surface of the water, and we were told for this question that there is 100%. But we don't always want to work in percentages. In this case, I can, because I can make my other A value also a percent. So I just have to make sure whatever I do with this A sub 0, I use the same units or the same format for this A of x. You'll notice I didn't put in the x yet. I'm going to put in the number that I get here. So back to the question, what else do I know? Well, I know that at a depth of 10 meters, there will be 25% visibility. So again, I look at my information. X represents a depth in meters. So my x is going to be 10 meters. Funny looking m. And that's also telling me the amount of light at that depth of 10 meters is 25%. So since I wrote 100 there, I put a 25 here. If instead I had written this as 1, then here I would write this as 0.25. So I just need to make sure I'm consistent. I'm doing the same thing with the A sub 0 as I am with the A of x. Final thing is the depth in meters where there's half visibility. Well, that's what we're asked to find in this question. So as we look here at number 10, at what depth will the visibility be half the visibility of the surface? So what we're solving for is this h value. So let's write our equation. A of x, I'm going to go with the 25, is equal to 100 as my a sub 0. This base of a half we were given in the question, and for a half-life type question, this will always be a half. And then in my exponent, my x value is a 10, and I want to find what is this h value. So this is the equation that I'm solving for. And initially we're asked to do this algebraically. So you'll remember what we did in previous questions. If I have some number multiplied to a power on one side, then I can divide that number out as my first step. So on the right side, my hundreds cancel out, and I have 1/2 to the exponent 10 over h. On the left side, I could write this as a decimal, but I don't want to because this base isn't a decimal. So instead, I'm going to say, well, 25 goes into 25 one time. Let me pick a different color. 25 goes into 25 once, into 100 4 times. So this is equal to a 1/4. And we can fairly quickly recognize that I can rewrite that 4 as a power base 2. So this is the same as 1 over 2 squared, equaling 1/2 to the exponent 10 over h. So notice I have a base of a half here. Here I don't have a base of a half yet. But what we did with some previous questions was if I have a 1 in the numerator, I could think of this as being a 1 squared. So as long as both of these are squared, this on the left is the same as 1/2 squared, which is equal to 1/2 to the exponent 10 over h. Powers are equal, bases are equal, so the exponents must also be equal. And so I can say my left-hand exponent, let me come up here, which is a 2, is equal to my right-hand exponent, 10 over h. And then, as I mentioned earlier, one option would be to think of this as a 2 over 1, and I can take the reciprocal of both sides to solve for that denominator. When I do the reciprocal of both sides, I'll have 1/2 is equal to h over 10. Multiply the 10 to get rid of this division. If I do it on the left, I also do it on the right. That's a 10 over 1. And we will get our h value is 1/2 of 10, which is 5. So let's think again, what does this 5 mean? The question was, at what depth? And so this is a depth in meters. So that's an important bit of information that we can generalize to say that these two pieces of information need to have the same units. And it'll be a similar situation that these two A values will also have the same units. Okay, because both of those in this case are amounts of light, percentages, and the X and the H in this question are both depths. So we can finish off our question with a sentence answer. The visibility of light will be 50% at a depth of 5 meters. So then we're asked as well to solve this graphically. So again, as we look at this starting equation, take a minute, enter it into your calculator. You have some choices. Again, you could do left side is y1, right side is y2, or you could collect everything to one side and then find the zeros. So take a minute, solve it by graphing, and then make sure that you get the same answer as what we have here. And here's what my graphs look like. And I am getting that intersection point where my x value is 5. So notice when I entered it into my calculator or here on Desmos, instead of entering an h, I needed to enter an x in the denominator. So I did need to use that independent variable as the missing value on that right side of the equation. All right, now there's a check your understanding question. So take a couple minutes, you can pause the video here and answer this question, then restart the video. So here's I work through this question. I'm going to use the same values or variables as we did in the previous question. And so let me just write down what the equation looked like. We said our future amount was equal to the initial amount. It's a half-life type question. So we're told it has a half-life of 3 days, and we'll have x over h in our exponent. So as we summarize here, half-life of 3 days, that is the h value. And I'm sticking in units here. You don't have to, but it helps me because it reminds me that this x value will also have to be in days. So even if I'm told other units, I have to make sure that I convert so that these two will have the same units. What I want to know is how long it will take. So how long, that's what I don't know. So how many days, that's this mystery amount. It's a funny looking question mark. For only 1/8 of the sample to remain. So this is my future amount. So this will be my a of x. In the future, I want 1/8 to remain. 1/8 of what? Well, 1/8 of whatever I had. So when we're given information like this, we'd say that I'm starting with 100% or 1, and I end up with 1/8 later. I have multiple options. I could have said something like, well, suppose my future amount was equal to 1. If that's 1/8, how much did I have initially? Well, I had 8 times as much. So I could do 8 and then a 1, but then eventually I'm going to take this 8 here and I'm going to divide it to the other side and I'll end up with a 1/8. So we usually won't do that. Instead, we'll just go with my initial amount is 100%, and in the future I'll have 1/8 of that. So those are the numbers that I get from my equation. If you didn't get these, then you can pause here, plug them in, solve the equation, and then restart the video to compare your answer with mine. So there's my equation. I have my base of a half, so I'm going to change this 1/8 into, well, 8 is 2 cubed, so this will be 1/2 cubed equals 1/2 to the x over 3. Power equals power, base equals base, so my exponent of 3 equals my exponent of x over 3. And I'll multiply both sides by 3 to get x is equal to 9. What does this mean? How long will it take? My half-life was in days, so this is 9 days. And I can write a sentence answer that in 9 days, only 1/8 of the initial sample will remain. Now, as you look at a question like this, you might say, well, I could guess and check and guess this and get this answer. And that's true. The reason we're picking questions with relatively easy numbers is so that we can see how the process works and we can fairly easily confirm it by guessing and checking. But don't expect that the numbers will always be this easy to guess and check. So we are expected to understand how to do this algebraically. So just as a quick summary to finish off, the previous page of notes, at the bottom of the page, we had characteristics of a half-life exponential function. So here I've written it in a different form, but basically it's the same idea. Something equals something times a half. To the exponent of x over h, it could be t over h, where t would be time. So y is the amount of a substance remaining at time x. Okay, so in this case, I'm saying x is a time. Typical half-life questions, we use this to be a time. In the first example we did in this video, we said that was a depth. Similar idea. Okay, this number here is the initial amount that we're starting with. So there's our initial amount. This is the amount at time x. H is going to be the half-life, and that's the amount of time it takes for the substance to decrease to half of its initial value. And we'd say that h can't be 0 because then we'd be dividing by 0 there. So that's generally how half-life equations work. And that finishes off this lesson. And there are some questions to practice listed at the end here.